First of all, I welcome all the students and the participants who are attending this live lecture. Students, are you here? Students, are you here?
जर तुमच्या UPI ॲपमध्ये काही अडचण आली तर आपल्या UPI ॲपमध्येच कंप्लेंट नोंदवा आणि आपल्या अडचणीचं समाधान मिळवा.
Okay, now see this. First of all, I welcome today in this live lecture we shall discuss the next bit live lecture, that is a Laplace transformation. Students, now we shall discuss what is meant by the Laplace transformation, and we have to find out what is meant by inverse Laplace transformation, basic formulae regarding the inverse Laplace transformation. आवाज येतो का रे? क्लियर आवाज येतो का कमी येतो आवाज? ओके, द इनवर्स लॅपलास ट्रान्सफॉर्मेशन. आवर एम इज टू फाइंड आउट the inverse Laplace transformation. We have to solve the problems based on inverse Laplace transformation. Actually we are here, that is the inverse Laplace transformation. Basically you must know the definition of the Laplace transform is L of f of t is equals to capital F of p, and we can define integral from 0 to infinity e raised to minus f of t dt. Now by using this Laplace transformation it is possible to find out the inverse Laplace transformation. So first of all I shall write the definition of the. आवाज क्लियर येतो का? आवाज मोठा येतो का छोटा येतो रे स्टुडंट्स? आवाज ओके आहे का? आवाज कमी येतो? So inverse Laplace transformation. What is meant by inverse Laplace transformation? First of all we shall write the definition regarding the inverse Laplace transformation, and then we shall move towards the problems based on the inverse Laplace transformations here. If the Laplace transform of you know that the Laplace transform of small f of t is denoted by capital F of p. We know that the Laplace transform of small f of t is equals to capital F of p. Then we know that actually capital F of p is called the inverse, then small f of p, small f of t is called inverse Laplace transform of capital F of p. That is how we can write this. Actually this is the definition, basic definition. If the Laplace transform of small f of t is capital F of p, then capital F of p is called inverse, then f of small f of t is called inverse Laplace transform of capital F of p. That means here if Laplace L of small f of t which is equals to capital F of p, then inverse Laplace transform of capital F of p is, this implies that inverse Laplace transform of capital F of p is small f of t, or small f of t is called as a inverse Laplace transform of capital F of p. So this is the definition of the Laplace transformation, where see this L inverse is called the inverse transformation operator inverse transformation operator. See this. Here in this case, L inverse is called inverse transformation operator. See this, again I shall define the concept of inverse Laplace transformation. If the Laplace transform of small f of t is capital F of p, according to the definition, see this, Laplace transform of small f of t is capital F of p, then small f of t is called inverse Laplace transform of capital F of p. So it is denoted by L inverse of capital F of p is equals to small f of t. This is the definition, and here L inverse is called as a inverse transformation operator. Okay, actually yesterday we have seen the basic definition, or in the previous lecture we have seen the basic definition of the Laplace transformation, Laplace transform of some typical functions. What is that here? We know that Laplace transform of 1 is 1 upon p. Here in this case, in the inverse, transform, how we can write this first formula? See this, that is L inverse of 1 upon p is equals to 1. See this, if Laplace transform of 1 is equals to 1 upon p, then we can write L inverse of 1 upon p is equals to 1. Do you understand this? Inverse Laplace transformation, here L raised to minus 1 or L inverse is called transformation, inverse transformation operator. Now this second formula we can convert into the Laplace, inverse Laplace transformation. You know that according to the definition of the Laplace transformation or some typical functions of Laplace transformation, Laplace transform of e raised to at, which is equals to 1 upon p minus a. Then student, you tell me how we can write Laplace transform of inverse Laplace transform of 1 upon p minus a. How will get inverse Laplace transform of 1 upon p minus a, which is equals to e raised to at. See this, each and every example or formula we can revert into the inverse Laplace transformation. Third formula, how we can write this third formula here? Inverse Laplace transform of, see this, inverse Laplace transformation of p divided by p square plus a square, which is equals to, how we can write, cos at. P divided by p square plus a square, we can write cos at. Simultaneously this fourth formula we can transform into the Laplace transformation, that is L inverse of a divided by p square plus a square. So we will get the answer sin at. Is it okay? Because the Laplace transform of sin at is equals to p divided by p square plus cos a square. We can write in this formula also, see this, or we can write this as 1 of L inverse of 1 upon p square plus a square, because a is the constant. So we can write this formula again in the form 1 by a sin at. can write in this way also. But for our convenience to understand the formula or comparison between Laplace transformation and inverse Laplace transformation, you can use this formula. But for the solution of the problem or purpose of the solution of the problem, you can use L inverse of 1 upon p square plus a square is equals to 1 by a. Okay, so we can write this formula only, but alternatively we can write this. Next, fifth, actually this can be written as n gamma function of n plus 1, which is also denoted by gamma n factorial divided by p plus 1, n plus 1. So now you tell me, student, in the Laplace transformation, L inverse of n factorial divided by p raised to n plus 1, we can write t raised to n, or in alternative method we can write this as, how we can write this formula? See here, Laplace L inverse of 1 upon p raised to n plus 1, 1 upon p raised to n plus 1, which can be written as t raised to n divided by n factorial. So we can write in easy way, that is equals to t raised to n upon n factorial. That means L inverse of 1 upon p raised to n plus 1, that can be written as t raised to n divided by n factorial, because n is n factorial or n is the constant term. So you can take on the right side also. 6, L inverse of, who can tell me this formula, student? P divided by p square minus a square, then we can write, how we can write? Cos hyperbolic at, means cos hyperbolic of at. 7th formula, similarly, Laplace transformation of sin at, h sin at, we can write, how we can write, students? So we can write in the L inverse of a divided by p square minus a square, which is equals to sin h at. So we can write this as a sin h at. You can write it. इथं थोडं पेन व्यवस्थित चालत नाही. You can understand this. Okay. Now similarly, the same process for these types of a function, it is possible to write the Laplace transformation. You can write for each and every function the Laplace transformation. If Laplace transform of e raised to at into f of t, which is equals to f minus a, this is the first shifting theorem. So we can write this first shifting theorem also in the Laplace transformation, inverse transformation. So I can go through the inverse Laplace transformation formula and its properties Okay, so we shall discuss the formulae and properties of inverse Laplace transformation. Actually these are the basic formulae regarding the Laplace transformation, and on the right side this is the inverse transform, Laplace transform. Okay, so it is the inverse Laplace transform. L inverse is called as the inverse Laplace transformation operator. Now we shall move towards the condition 1 condition. So this shifting property, how we can shift this property, we shall discuss here, we shall write here. So properties of inverse Laplace transformation. Number 1, inverse Laplace transform is also a linear transformation. Inverse Laplace transformation is also a linear transform. That means we can write L inverse of, see this, how we can write C1 capital F of P or F1P plus C2 capital F2P. Then we can write C1 L inverse of capital F of P plus C2 L inverse of capital F of P. Okay, this shows that Laplace transform is the linear transform, so it satisfies the condition of a linearity. Laplace transform satisfies the condition of linearity. Next we shall discuss the Laplace transform of next condition, that is a shifting property for the Laplace transform. We have to discuss here. Second, first shifting theorem. First shifting theorem, 1 minute. First shifting theorem. Now we shall discuss what is meant by the first shifting theorem. Now our aim is to discuss the first shifting theorem. In the Laplace transform, the first shifting theorem is L of e raised to at into f of t, which is equals to f of p minus a. Now in the inverse Laplace transform, we can write this first shifting theorem as L inverse of capital F of p minus a, which is equals to e raised to at into small f of t. So this is the first shifting theorem. That means Laplace transform of e raised to at into f of t, which can be written as capital F of p minus a. So it is t. Third, now we shall move towards the second shifting theorem. पेन का व्यवस्थित चलत नाही रे. 1 minute हा स्टुडंट्स, जरा पेन व्यवस्थित चालत नाही. सेकंड शिफ्टिंग थेरम. Okay, second shifting theorem. Now we shall discuss the concept regarding a second shifting theorem. You know that according to the Laplace transform, L of f of at we can write 1 upon a into capital F of p divided by a. But by the second shifting theorem, we can write this as L of, see this, second shifting theorem, L inverse of e raised to, what is that series? L inverse of e raised to, 1 minute. Actually, the second shifting change of scale property, second shifting theorem is L inverse of capital F of P, L inverse of e raised to minus AP into capital F of P, which is equals to small f of t minus a into h into t minus a. 1 minute, 1 minute, हे थोडं पेन नाही चालत. h of t minus a. See this, according to the second shifting theorem, L of h into t minus a is equals to e raised to minus p divided by a. If we consider g of t is equals to capital F of t minus a, then this g of t means capital F of t minus a, we can write Laplace transform of this. This is a capital F. So L inverse of a raised to minus ap into capital F of p, capital F of p, which is equals to capital G of t. And capital G of t means which is equals to f of t minus a. F of t minus a, where t is greater than a. So this is the Laplace transform for second shifting theorem, and we can write this in this way. So, or we can write in this way also, if t is greater than a, if we can write t minus a. So this is also a second shifting theorem, we can write in this way, f of t minus a into h of t minus a. हे थांबा, इथं थोडं व्यवस्थित येत नाही. See this is, or you can use this formula also, L inverse of L inverse of a झालंय, sorry, इथं a, L inverse of e raised to minus ap into f of capital F of p, which is equals to capital G of t, but capital G of t which is equals to f of t minus a when t is greater than a, and if t is greater than 0, then it is also, we can write f of t minus a into h of t minus a, according to the second shifting theorem. Now we can write fourth, Laplace transform of, say this, Laplace transform by using this, L of f of at, which is equals to 1 by a f of p by a. So in the Laplace inverse Laplace transformation, we can write L inverse of f of p by a, which is equals to, we can write this as a into f of at, a into f of at. But by using the particular substitution, this can be also written as, यालाच आपल्याला असं सुद्धा लिहिता येतं, p by a, we have to remove this p by a, L inverse of p by a. Okay, so this formula we can write in the Laplace transform, inverse Laplace transform, such as L inverse of a into p, or L inverse of capital F of a into p, which can be also written as 1 by a small f of t by a. You can use this formula or this formula. This is the Laplace transformation. Actually, this is the change of scale property in the inverse Laplace transformation. So we can write number of problems regarding this in the inverse Laplace transformation, or inverse Laplace transform. See this, again you can write this property. In the inverse Laplace transform, see this, we can write here L of f dash of t is equals to p into capital F of p minus f of 0. So we can write this in the Laplace transform f of 0, which is equals to 0. So we can write, if this formula, 12 number formula, 5 बघा काय येतं, if L inverse of capital F of p, which is equals to small f of t, then we can write L inverse of p into capital F of p, p into capital F of p, which is equals to, according to the 12 number formula, L of p into capital F of p is equals to, f of 0 is a constant term, that may be 0, f of t is, that will 0, so we can write f dash of t, sorry, small f dash of t, where f of 0 is equals to 0, or we can change as per its value. It actually f of 0 is the constant term, so we can change as per its value, there is no any problem. Now sixth, we can write the sixth formula. According to this integration, according to this formula we can write, how we can write here, L of f dash of f of t divided by t, which is equals to integral from p to infinity capital F of u du. So in the inverse transform you can write this formula in the inverse transform also, if small f of t is a piecewise continuous, and is of exponential order e raised to c naught t. This is a condition for integration series, such that limit t tends to 0, f of t divided by t, f of t divided by t exists. Then we can write for p greater than 0, L inverse of, see this, L inverse of capital F of p divided by p, which is equals to integral from 0 to infinity small f of u du. Okay, so we can write this as L inverse of capital F of p divided by p, which is equals to integral from 0 to t small f of u du. हे थोडं हे होत आहे पहा, पेन व्यवस्थित चालत नाही. ओके, नाउ वी शॅल solve the problems based on this. Now actually our aim is to, actually there are number of formulas regarding the inverse Laplace transformation, but you have to know these basic formulae regarding the inverse Laplace transformation. And now our aim is to find out the solution of some problems based on this. Now solve this, obtain the inverse Laplace transform of, obtain the inverse Laplace transform of the following. Simple. First, 1 upon p square plus 64. Now our aim is to find out inverse Laplace transform of 1 upon p square plus 64. That means L inverse of 1 upon p square plus 64. So we can write L inverse of 1 upon p square plus 8 square. Now here we have to use the basic formula for the inverse Laplace transformation. See here, what is that? L inverse of a divided by p square plus a square, we can write sin a t, or L inverse of 1 upon p square plus a square, you can take a on the left side. So we will get 1 upon a sin a t. हाँ सांगा रे स्टुडंट काय येतं मग आता याचा रिझल्ट. सो अकॉर्डिंग टू दिस लॅप्लास ट्रान्सफॉर्म वी कॅन राईट 1 upon a means 8. Now 1 divided by p square plus 8 square means a square means 1 by a sin 8t. 8t means 8t. So we will get the result sin, 1 minute, sin 8t divided by 8. This is the inverse Laplace transform of 1 upon p square plus 4 square. Okay, do you understand this? समजलं का रे students? If you have any doubt, then you can ask me. Similarly, we can find the Laplace transform of, for which term? We have to find out the Laplace transform of, next problem. Second problem. L inverse of 2 divided by p square plus 4. हाँ चला रे स्टूडेंट सांगा बरं त्याचा आन्सर काय येतं. p divided by 2 square plus 4. Actually our aim is to find out the Laplace transform of p divided by p square plus 4. So answer L inverse of 2 divided by p square plus 4. So you can take 2, this is the constant, out of inverse 1 divided by p square plus 4. So 2 into L inverse of 1 divided by p square plus 2 square. So now we have to use this formula 1 divided, go sec. आता येतो का रे, मध्येच येतो का कधीही? हा, गौसेक, मनीषा राठोड, नियमित रेग्युलर करायचं सुरुवातीपासून, मध्येच यायचं नाही, लक्षात येतं मला पण. सो 1 upon p square plus a square, then in the inverse Laplace transformation we can use this formula L inverse of 1 upon p square plus a square. You can take this a on right side, so 1 by a sin a t. So in this case we can write, हाँ चला रे सांगा काय येतो. Keep these 2 as it is. 1 by a means 1 by 2 sin a t. Sin a t means 2t. So 2 will be get cancelled, sin 2t. Or you can use directly this formula. असं न करता 2 कॉमन न करता डायरेक्ट 2 मध्येही जरी ठेवलात, समजा 2 इथं ठेवला असाल, if we put this 2 here, 2 divided by p square plus a square, then it will be, we can write in the form of sin 2t, sorry, cos 2t, no, this is a sin 2t. Next, third, L inverse of 4p divided by p square plus 25. Now our aim is to find out the Laplace transform of this. Student सांगा बरं आता फास्ट काय येतं तर. So L inverse of 4p divided by p square plus 25. So you can take 4 out of inverse transformation. So p divided by p square plus 25. Here you cannot take a p common because p is not a constant. This is a Laplace transform variable. Okay, this is a Laplace transform variable. So p divided by p square plus 25. So keep this 4 as it is L inverse of p divided by p square plus 25. Means we can write it as a 5 square. Now you tell me, students, which formula we have to use here in the Laplace inverse Laplace transformation. कुठला फॉर्म्युला आहे तो सांगा बरे. इन द इनवर्स लॅपलास ट्रान्सफॉर्मेशन, in the inverse Laplace transform, L inverse, we have to use this third number formula, this formula number 3, L inverse of p divided by p square plus a square, whose result is cos at, and a is this function. So we can write, now you tell me, student, which result we have to display here. So we can write this, keep this 4 as it is, p divided by p square plus 5 square, we can write it as cos 80, here a means 5t, that is equals to 4 cos. Okay, very good. Silpa Panchal, Bhagyasri Panchal, Yogeshwari, Rakshe, Vaibhav, Botsre, very good. Okay, so in this way we can write the Laplace transform of any function. You can calculate this Laplace transform of any function. Next, problem number which 4. Now we have to find out again the Laplace transform of the function. 1 minute. So next problem we have to solve Laplace transform of okay. If capital F of p which is equals to 1 upon 2p plus 3, then find L inverse of capital F of p. Now here actually we have given capital F of p is equals to which is equals to 2p plus 3. Now L inverse of capital F of p which is equals to L inverse of 1 upon 2p plus 3. Now see this, we have to use the standard form of inverse Laplace transform. Standard form of inverse Laplace transform. That means 1 upon 2p plus 3 means 1 upon p plus a. How we can convert this? Which formula here we have to use? Actually we have to use this formula, f of p minus a 1 upon p plus a. 1 upon p plus a. So 1 upon p plus 3 by 2. 3 by 2 means the 6th. Actually it is the shifting theorem here. 1 upon p minus a, which we have to use a second number formula. L inverse of 1 upon p minus a, which is equals to e raised to at. Here we have to use the second number formula. L inverse of p minus a is equals to e raised to at. But we need only p. Here we have, according to the second formula, here we have, in this problem there is a 2. So take this 2 common from the denominator, it will be 1 by 2 L inverse of 1 upon p plus 3 by 2. Actually we know that L of e raised to at, which is equals to 1 upon p plus a. Is it okay? So L inverse of p minus a, actually this is a p minus a. Again you have to see this formula. Second formula, see this, L of e raised to at is equals to 1 upon p minus a. So its inverse Laplace transform 1 upon p minus a. Inverse Laplace transform of 1 upon p minus a is equals to e raised to at. So we have to use this formula here. L of e raised to at is equals to p minus a, 1 upon p minus a. So 1 upon p minus a, which is equals to e raised to at. L inverse of. So we have to use this formula. Here a means minus 3 by 2. We need minus. So first of all I shall adjust this 1 by 2 L inverse of 1 upon p minus 3 by 2. Here in this case 1 of L inverse of 1 upon p minus a. A means minus 3 by 2. So its Laplace transform is 1 by 2 e raised to minus 3 by 2 t. We need p here. So for 2p you have to take the common. समजता का रे प्रॉब्लेम? हे समजलं का? असे खूप प्रॉब्लेम आहेत. You can solve. You have to solve all such types of problems, then you will get the result. Okay? असे प्रॉब्लेम्स आहेत, ते प्रॉब्लेम्स आपण एक एक घेऊ. नेक्स्ट third, which problem, which is this problem number 4, problem number 5 suppose. Now our aim is to find out the Laplace transform of L inverse of p minus 5 divided by p square plus 6p plus 13. Actually we have to find out the Laplace transform of p minus 5 divided by p square minus 6p plus 13. Now L inverse of p minus 5 divided by p square plus 6p plus 13. See this. Actually we have the formula in such a way that denominator must be in the form of p square and a square. So it is not necessary, we can't use direct formula for p square plus 6p. First of all, we have to convert this, we have to reduce this 6p in the square form by completing square bracket. So, suppose this is the first term p square, second term is 2 into 3p means 6p. So, its corresponding value is 9 for the completing square. You know that for last term, which is equals to, there is one formula, 1 by 2 coefficient of p bracket square. So, 1 by 2 coefficient of p is 6 bracket square, that is equals to 9. So, we have to add and subtract 9 here. L inverse of p minus 5 divided by p square plus 6p plus 9. For this plus 9 we have write minus 9 plus 13. So, this bracket will be the complete square bracket. How we can write this? L inverse of p minus 5 divided by p plus 3 bracket square, p plus 3 bracket square plus 9 plus 13, sorry, minus 9 plus 13, that is equals to 4. Now here in this case, p plus 3 bracket square, suppose this is a p plus 3 means suppose p, then we can use the shifting theorem. We can use shifting theorem. So we have to first of all adjust for the shifting theorem. Denominator is p plus 3. So we have to adjust p plus 3. For this plus 3, we can take minus 3 minus 5 means we can take 8 divided by p plus 3 bracket square plus 4. Now we have to use the Laplace transform for shifting theorem. Laplace transform for shifting theorem. How we can write here? L inverse of f of p minus a. L inverse of f of p minus a, then we will write e raised to at into f of t. E raised to at into f of t. That means in the form of Laplace transformation. P minus a, then e raised to a. Minus p minus a means e raised to a. So we have to write by the shifting property. See this? L inverse e raised to minus a means what? Plus 3 minus 3t. Again inverse Laplace transform of which term we have to use? We have shifted p plus 3 into p. So p minus 8 divided by p square plus 4. This is the shifting. We have used that shifting term. So e raised to minus 3t. Again we can write this as L inverse of, how we can write here? Again we have to write this p divided by p square plus 4 means 2 square, we can separate this, minus 8 divided by p square plus 2 square. Again, okay. Now Laplace inverse transform is also linear transform. So we can write L inverse of p divided by p square plus a square, sorry 2 square, minus 8 into L inverse of 1 divided by p square plus 2 square. Now student, now you tell me which formula we have to use in the inverse Laplace transform of a first term. So keep this e raised to minus 3t. We will get, काय तो स्टूडेंट सांगा बरं आता, L inverse of p divided by p square plus 2 square means which term? Say this again. Say this, 1 minute. L inverse of p divided by p square plus a square means third number formula, that is a cos at. Okay, again L inverse of 1 upon p square plus a square, 1 by a sin at. Okay, right, Silpa Panchal, very good. So we can write this as cos at. A means 2t minus a as it is. Again 1 upon p square plus a square means 1 by a means 2, sin 2t. So the final answer of this is e raised to minus 3t cos 2t minus 4 sin 2t. ठीक आहे, थोडं पेन फास्ट चालत नाही. दिस इज द इनवर्स लॅपलास ट्रान्सफॉर्म ऑफ दिस फंक्शन L इनवर्स ऑफ, 1 minute, L inverse of p minus 5 divided by p square plus 6p plus 13. ओके, अशा पद्धतीचे तुम्हाला प्रॉब्लेम्स घरी सॉल्व करता येतील. त्या पद्धतीने तुम्ही एक 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 प्रॉब्लेम सॉल्व करू शकता. इफ यू हॅव एनी डाऊट देन यू कॅन आस्क मी. आता याच्यावरचे प्रॉब्लेम्स उद्याला विचारू, आणखी सॉरी उद्याला घेऊ, पण इनवर्स लॅपलास ट्रान्सफॉर्मचे सर्वच्या सर्व तुम्ही फॉर्म्युले तयार करून घ्या. You have to understand all these formulas regarding the inverse Laplace transformation. You have to keep in mind simultaneously Laplace transformation formula and inverse Laplace transformation formula. Okay, अशा पद्धतीने सायमल्टेनियस दोन्ही फॉर्म्युले लक्षात ठेवा, म्हणजे लक्षात राहील. आता याच्यावरचे प्रॉब्लेम्स आहेत, बरेचसे आहेत, ते नंबर ऑफ प्रॉब्लेम्स आहेत, ते आपण उद्याला घेऊ. आज इथं थांबू. ओके, गुड बाय.